Question 2, it says the cost of Tony's Pizza here depends on the number of pizzas it produces each week. Specifically, it has a fixed cost of $1,000 and a marginal cost that starts at $1 and increases with the number of pizzas that are produced, as described by the following equation. So we have this: the total cost equals 1,000 plus the quantity squared divided by 40. Then we have the average cost is, well, if you take all this and divide it by quantity, you get 1,000 divided by quantity. Quantity divided by quantity is 1. Quantity squared is going to, if you divide that by quantity, you get back to just quantity without the squared divided by 40. So that's your average cost. And then you're just going to have to take my word for it right now that this is the marginal cost for this function. Now, for the sake of this walkthrough, to explain how to do this without just giving you all the answers, I'm going to do a slightly different functions, different cost functions. So I'm going to change the 1,000 to 500 and this 40 to 20. And that then means that the average cost, that goes down to 500, and this goes down to 20, and this would then go down to 10. Okay, so I'm going to use these cost functions to answer the rest of the questions. It says, using the equation for Tony's total cost, show that its average cost and marginal cost are equal to the above equations. Now, this is more of optional instead of extra credit. I'll show you that in a second. And so it gives you a start of a spreadsheet. You're going to need to copy what's in there into your own spreadsheet. And so I've got a spreadsheet started with these functions here. So let me switch over to, here I have the start of our spreadsheet here, and this has our equation for the total cost brought into it. So for the average cost, it says the average cost is equal to our 500. These are the equations that I showed you that we were going to be doing for this problem, right? So the average cost is 500 divided by quantity. I need to put that divided by quantity in here. So this is divided by the quantity. So I'm going to click on the quantity here to put quantity into this, plus 1. And then I need quantity divided by 20. And so we have plus, again, for the quantity, we click on the quantity row A3, and we divide that by 20, and that gets us our average cost. If you put a total cost of 1,100 and you have 100 is your quantity, your average cost is going to be 11. So we pull that equation down, and this gets us the average cost for all of the different levels of production. And then we have our marginal cost. So our marginal cost function here was the marginal cost equals 1 plus quantity divided by 10. So if I come over here, again, I want it to solve for the equation. So when you want to solve, you start with the equal sign. So it's the equal sign, 1 plus, we use the click on the quantity, get A3 in there for my quantity, and then divide by the 10. And that gets us our marginal cost, and we pull this down. So it said in that optional part, question A, show that this is actually the average cost and the marginal cost. So we could calculate average cost a second way. Average cost is equal to, if you take your total cost divided by 0, this is going to give me an error because it's dividing by 0, but for all the other ones, if we pull that down, right, we've got 11 here, 13.5 here, 13.5, right? It's giving you all the same numbers in these two different ways of calculating average cost. So that formula was correctly the average cost. Now, how can we figure out if the marginal cost here is correctly 11, if that function is correct? Well, if 100 costs 1,100, to find the marginal cost, we would want to find out what would be the total cost if we produced 101 units. So if I put 101 units here, we see the difference, right, is that the cost from 100 was 1,100. Now it's 1,111. The marginal cost was 11, right? So if we look at what's the marginal cost at, let's say if we put in 1,001 units. So this is one more unit than 1,000. What was the marginal cost? It went from 51,500 to 51,601. That is, the marginal cost there was 101, right? And so we see that this is giving you more or less the same marginal cost as what's that's calculated. So that confirms that those formulas are giving you the correct average cost and the marginal cost. So let's go back to our questions here. So we've done this question, right? Calculate the average cost, marginal cost for the pizzeria when it produces 0, 100, 200, 1,000 pizzas a week using the above equations. Notice that you can't just, right, if you do for the marginal cost, if you go, this amount minus this amount, that won't correctly get you the marginal cost because this is a jump of 100 units, not just 1 unit, right? The marginal cost is supposed to be the cost of 1 more unit. Okay, so let's look at the next question. If Tony's Pizzeria is a price taker, that means it's perfectly competitive. It is too small. This one pizza shop is too small relative to all the pizza makers in the city to affect the price of pizza in the city, right? So what is its supply curve? Its supply curve is going to be the marginal cost curve. Think if you can explain why that is. There's the previous lectures talks about why the marginal cost curve is the supply curve. So that is, if we go back to our equation, that for the price of $11, they're going to produce 100. For a price of $21, they produce 200. This marginal cost curve is saying for each price, this is the quantity that it would produce. So this is your supply curve. So let's come back here. Okay, suppose the price of pizzas is $46. How many pizzas will Tony sell? How much profit will he make? So let's take a look here. So if the price of pizza was $46, Tony wants to produce whenever the price, remember the price is going to be Tony's marginal revenue. So he wants to keep producing as long as that price is greater than his marginal cost. So here, if the marginal cost is $11 and the price of pizzas is $46, you're going to want to produce more. If marginal cost is $21, the price is $46, you want to produce more. Marginal cost is $31, that is less than the price of $46, you want to produce more. Marginal cost $41, still less than the price, you're going to want to produce more. $51, this is too high. This marginal cost here is more than the price, so you will not want to produce that. So go back to this amount. Tony would want to produce 400 units. Now, remember that the numbers in your example are going to be different than this, right? So you're going to get a different answer, but the logic of as long as the marginal cost is lower than the price, you want to keep going, right, to get as close to that price, but you don't want to produce if the marginal cost is greater than the price. So here, how can we figure out the amount of profit? So remember that the profit equals the quantity times price minus the average cost, right? And so in this case, that would equal, our quantity is 400. We get that from that, times the price is $46 minus your average cost here, 20. So the profit here is 9,500. This is the profit that Tony will be making. And so the difference between the price of $46 and the $22.25, that is the profit margin, and you multiply that by the quantity of 400. So let's go back to our question here. Suppose the price of pizzas falls to $21. How many pizzas will Tony sell? How much profit will he make? Okay, so he's going to want to keep producing as long as the price is greater than the marginal cost. He's going to want to keep producing, right? So here the price is greater than the marginal cost. At this point, the price is equal to the marginal cost. So this is where he would stop producing. At $21, he'd produce 200 pizzas. So our profits would equal the 200 times the $21 minus our average cost of 13.5. And he's still making a profit. Think of what's going to be happening in this town. The pizza shops are making profits with these prices. So that's going to make other people want to come into this market. And so it says, assume now that there are a lot of people in the town who work crummy jobs with no employment rents, and they are just as capable as Tony at running a pizzeria, i.e. they have the same cost curve. What will be the price of pizzas if firms enter the market whenever there is profit to be made? So everybody else is seeing those profits, and they're going to want to come in and open a new store if there's profits to be made. Why would they want to keep working in their, no employment rent job when they could open a pizza store and make profits? So people are going to keep entering until there's no profits to be made. At what point would no profits be made? For that to be the case, it has to be that your profit margin, remember the profit margin is your price minus your average cost. This has to fall to zero. When the price equals the marginal cost, the profits are equal to zero. So that would be when the price is when we have that the average cost is the same as your marginal cost. So in this example, it's when the price equals $11 is when the zero profit. So firms are going to keep entering until the cost of pizza falls to $11. And at that point, Tony would make 100 pizzas. Go back to our questions here. So in our example, what will be the price of pizza firms enter the market whenever there's profit to be made? It'll fall to the $11. So suppose the price of pizzas converges to a long-run competitive equilibrium price. That means the price where no profits are made. In our example, it's $11. Remember, you're going to have different numbers in your problem, so you're going to have to solve it for different numbers, but that is it's going to be the zero profit is the long-run competitive equilibrium price. In our example, it was 100 pizzas. You have to answer for your example, how many pizzas will Tony sell? How much profit will he make? Well, I can, tell you that right now without you having to solve for your numbers that the profit he's going to make is zero. In the long run competitive equilibrium price, there are zero. So here it says, if the weekly demand for pizzas is given by the equation, quantity demanded equals 3,550 minus 50 times P, how many local pizzerias will stay in business in the long run? What is 3,550 minus 50 times P? We can plug in. We know that in the long run competitive equilibrium, the price is going to be 11. So if we put 11 in here, 11 times 50 is 550. So the quantity demanded would be 3,000, right? It'd be 3,550 minus 550. The quantity demanded is, in this city, 3,000 pizzas are going to be purchased. So how many local pizzerias will stay in business in the long run? Well, for that, okay, so we know that there are going to be 3,000 pizzas bought. How many pizzas is each pizzeria going to make? That can tell us, right? If we can divide that by how much does each pizzeria make, that can tell us how many pizzerias are going to stay in business. So let's look at we said our long run equilibrium is this $11. All the pizzerias have the same cost curve, so they all are going to produce the quantity of 100. So if each pizzeria is making 100, that means that we have 3,000 pizzas being purchased, each pizza place making 100 pizzas. That means this town is going to have 30 pizzerias.
You can ignore the last question about the economic surplus and perfect competition. Okay, good luck.